So this is a 2 to 4 paper, and then we'll just try to. Supposedly we can finish it in 1 hour, 15 minutes, but I have some teachings, okay, here and there. I'll just keep it minimal, okay, but so that might be like 1 hour and 50 or 30 minutes kind of thing, okay, but actually should be easy. Okay, chemistry is something from history, okay, so um, you get it, and then you get and therefore they also cannot go to too deep. Okay, so that's why it's just something touch and go. Whether you know this and you know that you realize that you can use everything by memory, but if you have a good master to teach you how to think, and then you just realize that it doesn't need much. We don't have much things to remember all these things. Anyway, okay, so it's a 2023 paper. Try my pen. Okay, my pen. Wow, what is this? It's wrong. Well, this is supposed to be line. Okay, so okay, lines okay. So anyway, to read paper, let's start. Okay, so it's very simple. Wow, the formula of some elements and compounds listed here. Okay, answer the following questions. Use the elements or compounds for the list. Okay, so the idea is that what is elements, what is compound. Okay, so we have elements and compounds. Okay, particle exists, or actually particle you want to call with only one element symbol. Element symbols only have the capital letter. The next letter, which is a small letter, right, actually belongs to the same element. So Na together is actually one element. Okay, so you see small letter, capital letter. So you just need to see how many capital letters. That means how many elements are there. And then when you have a compound, things like compound, you have a different kind of it's not about the number, it's about different elements consist of inside uh one particle. Okay, then we call it a compound. Okay, but remember when we talk about ionic compound, so some Na2CO3, these kind of things, right, it's actually a basic ratio of a repeated unit. Okay, so it's not really one particle in this way, but we still treat it in this way, treat it as if one particle keep repeated, like sodium chloride, sodium chloride. So one sodium, one chloride, we call it a pair. Okay, so we just see them as one ionic particle if that's the case. Okay, metal non-metal is ionic, and non-metal is covalent. Okay, so we have all these things. Okay, very simple. Answer following question using elements or compound from the list. Each element or compound may be used once or more than once, or not all. Okay, react with dilute hydrochloric acid and produce hydrogen gas. Hydrogen gas after reactions is actually quite rare. Okay, this is rare. Okay, so that's why we have a special kind of the special chapter that will tell you what actually give hydrogen gas after reactions. Okay, so it's about metal with acid. Okay, acid, right? So in the chapter acid actually says that metal with acid is give hydrogen, and this is just remember that it's very rarely you get a product as a hydrogen gas. So hydrogen gas come out is due to metal with acid, but not all metal. Okay, so then we test you. The second thing is actually the metal reactivity series. So we do have a metal reactivity series here. Okay, metal reactivity series. Okay, be careful about this. Okay, metal reactivity series. My pen is no good. Okay, metal reactivity series. Metal reactivity series. Okay, so metal reactivity series is tell you that anything above hydrogen, anything above anything above hydrogen, okay, will react with acid. Okay, anything below hydrogens will not react with acids. Okay, so you have the above and below one. Okay, some people have a very hard time to remember metal reactivity series. Okay, then you gotta understand. So the idea is that first take out all the metal first. So this is metal. This is metal. Okay, so this sulfur is not. Okay, sulfur don't exist as S alone. Okay, so this is weird. Sulfur exists as S8. Okay, but anyway they talk about sulfur atom. Okay, so can't say anything. So these are only two metals, and copper is just the guy that below hydrogen. Okay, magnesium is actually quite high. Okay, so how to remember metal related series? That's the idea. Okay, so for me, actually, there is a way, because other than you talk about acid reactions, right? In the chapter of metal, you've got other things to remember. Okay, so how to remember metal related series? We just need to remember something called zinc antin lead. Okay, that's very weird. Okay, so why? Okay, because metal series we focus on the first 20 elements here in the periodic table. So left hand side is metal. So you see the first 5 guys are arranged for you already. Okay, so group 1, potassium, sodium, calcium, magnesium, aluminium. Here. Okay, so the 5 guy of metal relativity series is already in order. Okay, so because the leftmost is actually the more reactive. Okay, the right up is actually less reactive. Okay, because of the electron, which is how easy the electron is being given away. So you have more ring going down the group, okay, you can just throw it easier. And it's more left, right? That means you just need to throw away 1 electrons easily. Okay, so that's why left is easier and go down is easier. So potassium is the most reactive metal in the first 20. So first 20, okay, so potassium first. So potassium, sodium, calcium, magnesium, aluminium. This is the order of metal utility series for the first 5 guys. So the first 5 guys is being handled by here. Okay, first 5 guys handled by here. After that, you got to remember is zinc, iron, tin, lead. Okay, zinc, iron, tin, lead. Okay, zinc, iron, tin, lead. Okay, so zinc, iron, tin, lead. After that, it will be hydrogen. Okay, and then the last 4 is not reactive one: copper, mercury, silver, gold. Okay, so some syllabus might have a lesser element, but this, if you list out all, it will be here: copper, mercury, silver, and gold. And then somebody bother is platinum, but they never bother to test on all this. Okay, so anything below hydrogen. So that's why we got 2 guys, and this guy is below hydrogen. So the only thing is Mg. Okay, done. Contain a halide ion. Halide is halogens, means group 7. Okay, group 7. Okay, group 7. Okay, group 7 is halogen. Halide, why is it lie? Because all the group 7 will become IDE form. Okay, IDE form, right? It means actually it's the elemental, is the element in pure element ion or anion. Okay, pure element anion form is always end with IDE. Okay, fluoride, chloride, bromide, iodide, and sometimes sulfur. They call it sulfate. Then it will be ATE form, so not IDE. But if you talk about sulfur as a group 6 and it's 2 minus these things, it's called sulfite also. Okay, so sulfite. Okay, so anything with IDE, sulfite. Okay, it means the elements anion form. Okay, no nothing O in front or hydrogen here and there. Okay, so it will just be IDE form. So halide means it's group 7, halogens, the IDE form. So that means a single ion element form is group 7. Group 7, what we have? Okay, fluorine, chlorine, bromine, iodine. Okay, so those are the halogens group. Okay, halogens group. So that's where we get the HA. So fluorine, chlorine, bromine, iodine. Okay, all this acetane. Okay, these are all the group 7. And the interesting thing about INE, these element groups only exist in group 7 also. Okay, so once you know it's something in, okay, you know it's group 7 stuff. Okay, I'm talking about chemistry. Don't ask me urine, those things. Okay, those are bio stuff. Okay, I don't care. Okay, so fluorine, chlorine, bromine, iodine. Okay, all these are halogen group 7 pure ion form. Okay, so you also heard something about chlorate. Okay, so chlorine with ATEN. Okay, that means it's chlorine with some oxygen. Once it's having something called ATE form. Okay, ATE form means actually have oxygens, many oxygen. And ATE, right? The number of oxygen is the maximum. For example, sulfate. Okay, sulfate is this. Okay, so actually it's the maximum number of oxygens that you can get into an anion complex or like a anion form. Okay, then it will be called ATE. Okay, one O oxygen lesser is called ITE. Okay, it's like not institute. Okay, but ITE is actually one oxygen less. Okay, and charge normally remain unchanged. Okay, so be careful with all this kind of ending. Okay? Anyway, halide, make it simple. Halide group 7, simple. So in this way, you see it is now this is chlorine supposedly, but that's not ion. Okay, so you might have this guy, but this might not be the good answer. Okay, even though you say it's NH4 plus and Br minus, but it might not be a good answer because it is non-metal and non-metal is supposed to exist in covalent form unless you dissolve in water. Okay, so it might not have a bromide ion. Okay, so it might not be a good answer. Then see what else is better. None. Okay, so this is sickening. Contains. So I have no choice. I have no choice. This is not fair. This is really not fair. Okay, I have no choice. It says that this is NH4Br. Okay, now check whether your the paper is it really set by some good teachers. Okay, so let me check with ChatGPT. Okay, so ask him, is NH4Br a covalent or ionic compound? Okay, he's right. Okay, it's an ionic compound consists of ammonium ion and the bromide ion. The bond between these ions is because it's involved electrostatic attraction between blah 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 blah. Okay, so this is just nice to be ionic, and it is not very fair because NH4Cl is covalent. Huh? I thought it's a gas. It's a solid room temperature. Okay, so it will be, yep, if it's solid, then of course it will be ionic compound. Okay. Okay, fine. Okay, I'm wrong. He's right. Okay, so this is the this is what I say. Okay, the best you have. Okay, there's no ambiguity. So this is the H4Br. Okay, so this is correct. Okay, it's an unreactive gas. Unreactive gas means that it is a noble gas. The best. Okay, it's a noble gas. Otherwise, you just find inert and non-reactive gas will do. Well, this is evil. This paper is evil. Okay. Supposedly you test a Br ion, you give me a metal and non-metal, right? You'll be simply here. How do we ever go to remember that NH4Br is actually ionic compound? Okay? If it is molecular structure, then it will be in a form of molecular donor. Okay, so things will be like this. Okay, NH3, NH4, sorry, NH4Br got no choice. Nope, it will be in this way. Okay, native. Okay, so then no, it will not be native. Okay, so okay, fine, I'm wrong. Sorry, you know, good. I don't care about me. Okay, so anyway, there is ammonium ion and there is bromide ion to go together. So that's correct. Okay, my guessing is really thinking too much. Unreactive gas. Okay, so the best is you get a noble gas, but I don't see any. Ar is argon, right? Ar is argon. Ar is argon. Yeah, it's here. Okay, so 40. Okay, 1840. So Ar is there, then of course it's Ar. Okay, because all these questions also got to help. Okay, chemistry is not physics. Okay, chemistry is not physics. I mean is that this is Ar. Okay, this will be the gas. Okay, so this guy. Okay, unreactive. How unreactive is unreactive? We call it inert gas. You talk about inert gas is totally unreactive. Unreactive can be less reactive. Okay, so CX4 actually is also quite unreactive. Okay. Okay. Anyway, I think this is what I call inert gas. So the best answer is still Ar. I don't want to write anymore. So Ar. Okay. It's an air pollutants and its main components of natural gas. It's the main component of natural gas. That means you do fossil combustions, it come out as a pollutant. That means some air which is not some particle which is not part of the air. Okay, so CO2, H2, N2, those kind of things are air compositions. Okay, so oxygen also. Okay, so they are gas, they are pollutants and pollutants. No, 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 no. This is N level paper. This is so evil. Okay, okay. Then it will become the best answer is this guy. Okay, stage 4. Methane. Okay, methane actually is part of a petroleum. After you burn, if it's non-completed, it will have some unburned remain. Okay, so methane is also flammable gas. Okay, so it's just like a big alkane chain break down to small air particles. So this is what you have. Supposing pollutants should be those NO3, NO2, NO2 gas. Okay, and also carbon monoxide. Okay, I don't see all here. Okay, I don't all see here, and some lead components. Okay, compounds also don't have. Okay, so this is the incomplete combustion side. I think this is the best answer we have. But this paper is not easy. Okay, it's not easy at all. I think N-level student last year is having a very difficult days also. This is not simply testing on the concepts. Okay, this is the best answer you have, and it's always the weird answer. Has a mass of 2 grams for every 0.125. Okay, so this is number of mole. This is mass over mr. Okay, so number of mole 0.125 equal to mass over mr. Okay, so the mr equal to 2 divided by 0.128, 125, sorry, 128. Okay, calculator. Just realized that if I can just draw so ugly things, so why bother about the pen? Okay, 2 divided by 0.125. 16. Okay, so that means my MR is 0.16. Which of the formula MR is 16? 16 is 16. Is not 16, not 16. Okay. This is not 16 also. 16. This is one guy 32. I remember sulfur is 32. Yep, sulfur is 32. Okay, chlorine is 35.5. Wrong. This oxygen is 16. But one guy 16 eh. Two guys 32 already. Okay, one guy 16, two guys 32. Yeah. Okay, so wrong also. Okay, so CH4. Aha, jala is CH4. Okay, carbon is 12. Hydrogen is 1. So 4. 12 plus 4 is 16. So this 16 I'm confirmed. Okay, so it's CH4 here. But then this guy cannot be the pollutants. Or maybe I use this again for the 2 round, but rarely people are doing this. Okay, it's an air pollutant and it's main component of natural gas. But it's a main is the main component of natural gas is CH4 also. Okay, CH4 actually make a very small chain alkane. So normally methane is one of them. Okay, methane, ethane, propane, and butane. So they are light enough to be natural gas for combustion. Okay, so CH4 actually this is also confirmed, but it's the air pollutants. It's rarely say okay it is okay because global warming you can blame them. Okay, people say it's the cow, all the cow farts too much, make it the global warming thing. This is the gas they come up with. Okay, so uh okay, I will have stage 4 here and stage 4 here. Otherwise, I got no choice. Okay, so 2 stage 4 here. Doesn't look nice, and the whole paper looks very scary and looks tricky and look evil. Okay, so guys, this is why I get answered. Okay, the boiling point of organic compound, this, and this are shown in table this. Okay, so boiling point this hexane and hexane, heptane. Okay, so this 6 carbon, this 7 carbon. Okay, 6 carbon, 7 carbon basic alkane chain. State the name of the homologous series is alkane. Okay, they are all called alkane. Just like group 7 called halogen, group 8 called noble gas. Okay, or this kind of whatever ANEane, okay, it's called alkane. ALK in front, and then you put your whatever. So it's ANE, so it's alkane. The second guy is called alkene, and the third guy is alcohol. Okay, so it's called alcohol, but the core where this K becomes C. Okay, and then one more is carboxylic acid. Okay, and then ester. Okay, these are the things in the syllabus. Hexane and heptane burns complete in air, complete the balance equations. So combustions is very simple. Anything combustions, you just all the particles just try to be the most stable state. So the idea is that all carbon becomes CO2, okay, and all hydrogen become water, okay. So 16 of them, right? And H2 here, right? So I got 8 guy. So make 16 of them. So oxygen, I got 2 sources. You got to add up first before you know. 7 of this carbon. So carbon, this guy got this is 1, right? So 7 times 1 is 7. So it becomes 7 this, it becomes 7 that, okay? But because of this number and this number, my oxygen is kind of affected. So 7 times 2 is 14. 14 oxygens here, and 8 times 1 is 8. So it's 14 plus 8 of oxygen. So it's got 22. Okay, simple maths. Okay, don't get correct. Okay, so this is correct, 22. So this is 11. Okay, because this is a 2 here. Okay, so 11. So my answer here is 11, 7 CO2 here, and an 8 here. Okay, this is my answer. Draw a dot cross diagram that shows the bond in one molecule of water H2O. Show only your outer cell's electrons. Okay, hydrogen, oxygens, and hydrogen. To me, I'll draw in L shape because this is lone pair. Dot and cross diagram, so I just choose my oxygen electron to be O, dot, 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 and cross. And cross. That's why I draw it in L shape. Okay. So the cross one actually is from hydrogen. It's from hydrogen, and there's sharing of electrons. Done. The boiling point of blah 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 organic compound a different homologous series as shown. I think this is shown as shown in table 212 the calculus. Okay. So okay, pentane, okay, Pantene, okay, Pantene. I think our shampoo is Pantene Pro V kind of things, right? We do have one for Pantene, okay. So Pantene is actually 5 carbon, okay. You see, like, okay, 2 to 4, right? They are in the formula of 1 to 2, okay. So H10, okay. So since its melting point is in this way, and the boiling point got to be between these two numbers also, okay. So we don't know what this. Give a physical state for butane at -40. Butane -40. -40 is below boiling point. Okay, since okay, -40 is between is boiling point of -6 and is melting point of minus 185. Okay, you put English word since I don't need therefore. Okay, otherwise you can just say this sentence then comma therefore. Okay, don't because therefore. Okay, don't do redundancy. Okay, so anyway, so and as a result, okay, sort of things like that. Okay, so it will be it should be in liquid state, or just say it's a liquid. Okay, physical state is liquid. Okay, plot a graph of boiling point against the number of carbon atom in each table mark across this. Oh, jalat, this one. Okay, -16 something, the countings, and then -104. Number of carbon. Anyway, just boiling point, okay. care about this one. Okay, so I think this one is 2 carbon, so 2. So we got 2, 4, 2, 4, 6, right? 2, no, 2, 3, 4, 5, 6, 7. So 2, 3, 4, 5, 6, 7. Okay, then you just go to the first guy. 2 is minus 169. 169. No, no, minus 140. 104. Minus 104 is 20. Okay, so it's 2 block. Okay, so it's 2 block here, so 2 block here. Okay, got a point here. Okay, then the minus 48, minus 48, 48, 48. Okay, okay, 2, 4, 6, 8. Okay, so things like here. Okay, maybe my mouse is off a bit. Okay, so you girls be careful. Okay, minus 6, minus 6, 2, 4, 6. Don't know what. Okay, the next one 63, 63, 63. Okay, so 62, 64 between 2 and 4 in the center of the two dot. Okay, a little bit here. And then heading 7 is 94, 94, 94, 2 block here. Okay, now my picture is slanted. Okay, so anyway, so it's supposed to be draw the best line. Okay, draw a graph and then go to, okay, then you put a best line. We want a graph, right? Sort of things like that. Okay, this is bad. I don't have undo. I have undo. Good undo. Good, good, good. Okay, I'm back. Okay, I can use this. This is bad. Haha. Now it's not so correct because you see my picture is slanted. Okay, it wouldn't be so ugly anyway. So assuming, wow, my line horrible. Okay, so my line is the best line. Should look quite. It should look actually quite nice. Okay, this is very bad, but just for the sake of illustrations, if this is already the best line, okay, so the idea is to ask me to estimate. Okay, okay, draw already. A curve line, best fit. Okay, best fit. Calculation, best fit. You make this chemistry. Okay, so don't really care about the mathematics, blah blah blah. But just draw a best line. Have the best number of points at the left and right, the kind of things. Okay, more or less the center. Account all to your plotted points. Okay, so if all your points plotted correct or okay, actually they have a error margin for you. Don't worry. Okay, so just plot that, and your line is the best there, and you get most of the mark. Okay, so don't worry. Hey, next one. Use your graph to detect boiling point of pentene. Okay, so point pentene is 5 here, so you cut the 5 here, so you have the point here. Okay, and then you draw the. So how do you do the graph? This is a trick, eccentric. Eccentric, right? For this graph, you need to draw dotted lines. Ugly. Okay, so this one. Okay, don't have dotted line for me. Okay, so bad. Also, assume this is dotted line. Come on. Assume this is dotted line. Okay, so this is like dotted all the way, and then you dotted all the way. So roughly like 0. Not 0. Okay, so I think this is, it's not like water. Okay, anyway, I might have minus 4 degree the count fix horizontally. Okay, so sort of things like here. Okay, if I have like minus 4, then I'll just say minus 4. Okay, I might not be right. Okay, I think quite far. Okay, pentane. Okay, pentane, right? So let's find the real one. Pentene. I want boiling point. Okay, don't care about the 1 or 2. Okay, just choose the 1. Okay, 30, the 33330. I think it's quite far. 30, 30. Hey, come on. 30 is roughly here. So my line actually should be drawn sort of things like that. Okay, so that's why I cut 30. Yeah, see so how accurate it is. This is funny anyway. So ta ta 30. Ta-da, thank you AI. Now so that's the way. Okay, you see because it's slanted, right? You pass through all the points. Actually, you see the curve also got the line this way, and then you roughly really by these 2 points, you roughly see that it's actually quite close to 30 of the number 5 pentene. Okay. The periodic table blah 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 over 100. The periodic table lists over 100 chemical elements. Each isotope of element. What's the isotopes? Isotopes, right? Actually, is just because they are the same. They are the same elements. Okay, same element means the same proton numbers. Okay, isotopes means it's actually the same elements, but they have different number of neutrons. So that's why the mass is different. Okay, so that's the that's the isotope. Okay, it's a proton number. Blah, 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 blah. Yeah, they just tell you what is isotope. I thought we were supposed to remember. State what is meant by the term nucleon. Nucleon mass number. Nucleon number or mass number. Nucleon number is the number of, sorry, is the sum of number of proton, proton and neutron. Okay. So number of proton and neutrons add together is actually nucleons, okay, or the mass number, or they are all called. Why is this weird terms called nucleon? Because they are all nucleons. Okay, nucleon means particle inside a nucleus. Particle inside nucleus means it's proton and neutron. Okay, same thing. Up to them, whatever they want to say. The atomic structure of an atom of element E shown below. 2881. 2881 tau. If you're familiar with this, 281 is potassium. Ha ha ha. Name element E. Potassium. Potassium. Bromine react with a sample of sodium to produce 2.5 bromine with a sample of sodium. Bromine and sodium, 2.5 more sodium. Write a balanced chemical reactions for this reaction. So they say sodium and bromine, right? Okay, sodium is Na, is metal. Okay, all metal just exists is its own elements dangling itself alone. Okay, aluminum Al. Okay, you don't have number behind. Bromine is a gas. Okay, gas is a non-metal. Non-metal exists itself in various form. Okay, sulfur is 8. Most of the gas are 2. Okay, the gases are 2. Inert gas is like the noble gases is 1. Okay, so they don't have any number behind. So bromine is actually group 7. So actually it's bromine Br2. This is the formula is fixed. Okay, and we produce sodium bromide. So sodium bromide. Okay, sodium is +1, bromide is 1 minus, cross multiply that, you know it's 1 to 1, right? So it's sodium bromide, there's no number there. Okay, so it's just 1 sodium with 1 bromide is 1 sodium bromide. Okay, so that's the reactions, right? Then you got to balance it. Okay, so 1 to 1 seems okay, but I got 2 guys here, I cannot half here. Okay, so I got to make it 2. Okay, I cannot half here. Okay, so make it 2. Okay, so when I make it 2, then the sodium need to get 2, so it's 2 here. Okay, so it's 2 sodium and Br like that, so 2 of them. Okay, so done. Okay, do you need to give the state? If you give a state, okay, this is gas. I think this is liquid, and this is solid. Not gas. Okay, come on, sodium is solid. Calculate the mass of sodium bromide produced. Sodium bromide produced is very simple. Mass, right? Mass. I have the mole. Okay, number of mole and mass. Okay, so my formula is number of mole equal to mass over mR. Okay, so that means number of mole 0.25 equal to mass. That's what I want. MR. What's MR? MR is sodium's MR is 23. Bromine MR I can't remember. Bromine 80. Okay. So it's 23 plus 80 and then times 2 0.25. Okay. 23 plus x0 and then multiply 0.25, 25.75 gram. Okay, that's the mass that it will produce. Solid sodium bromide does not conduct electricity. Describe one physical change when allow sodium bromide to become an, it cannot be an conductor. Okay, because conductor doesn't start with the vowel, is it? And become, anyway, become whatever and conductor. Okay, physical change which allows sodium bromide. So for this is ionic compound. Ionic compound, it does not conduct electricity in solid state. Okay, so it conducts electricity only when it's in molten form, which is the melted liquid state, some thick gel kind of, actually it's liquid salt kind of things. It's very rare. Otherwise, it's dissolved in water, become aqueous state. They have conduction by free ion. Okay, conduction by free ion. Free ion means the the ions in the ionic compound can swim around each other or swim around in water. So swim around each other because it's liquid. Swim around in water is because it's aqueous. Okay, so they break down, they can swim within the water. Okay, so that the positive can discharge, negative discharge, so the whole thing is like conduct electricity. Okay, physical change was allowed so that become, so in molten form means you just melt the salt. Okay, make sure it's no air, no such thing, no other things to do reactions. Okay, get it molten to liquid state. Okay, so conduction by free ion or mobile ion. Okay, some cheap words. Okay, or otherwise it's aqueous. Aqueous means dissolved in water. Okay, aqueous state. It's also by free ion. Okay, so dissolve in water or just melt it to liquid. Both way. Chlorine react with hydrocarbons such as chlorine gas react with hydrocarbon. The C3 is alkane. Alkane, right? This actually, never mind, okay? We got time to talk about history, then we actually tell you that actually don't quite react. So he anyhow find one reaction for you to learn, okay? So alkane, okay? So this is under UV light, then you produce substitutions, okay? State the type of reactions that occur between chlorine and ethane. Okay, so this is called, we actually have a name called free radical substitutions, but who can remember the whole thing? So anyway, we just call it substitution because the chlorine, one of the chlorine atom replace one of the hydrogens, so we substitute one hydrogen in the main chain. Okay, all the reactions naming is all talk about what happened to the main guy. Okay, those kind of subparticle we don't care. Okay, but anyway, this is a substitution, so you can see that the chlorine is substituted inside. Okay, so it's not oxidation, it's not combustion, it's not anything but a substitution. Okay, neutralizations, all these things are, are oxidations, reductions. Okay, combustions, uh, substitution, additions. These substitution, additions, right, are the things inside the organic chemistry. Okay, so mostly are like that, like this. And acid it have neutralization also. Okay, so these are non-organic, inorganic chemistries. So this is in organic chemistry. Okay, so we normally ask things like this. So substitution is the answer. In the gas G, okay, so by playing with the formula, okay, C go in, okay, then the H come out, right? Then H come out, and what Q must have? One Cl left over and one hydrogen get replaced out. So HCl will come out here. Is it hydrochloric acid? Of course not. Okay, it is hydrogen chloride because it's a gas. Hydrogen chloride. IDE. Okay, hydrogen chloride. Yes. Magnesium and steam are reacted. Okay, magnesium steam. Okay, so it's the metal react with steam. Okay, so this is a very reactive metal. In your metal chapter, we learn about metal react with water, metal react with water, metal react with steam, metal react with acid, right? I think so. Okay, so we learn about these three. And then in the acid chapter, we talk about acid with metal, acid well with base or alkaline. Okay, so there are some overlap here. So these are the 5 things that we learned here and there. Okay, so this is actually what that's metal with steam. Okay, what it will react. Okay, what it will react, and after reactions, what will come out. Okay, solid A. Okay, this is H2O. This is magnesium. Okay, and this is the things that we're going to remember. Hydrogen gas come out. Okay, steam. Okay, so this is ni magnesium oxide or hydroxide. Magnesium hydroxide cannot be got to be magnesium oxide. Okay, I also forgot. Magnesium steam. What does that? Okay, I just don't know first. Leave it here. See whether I got any hints later. Okay. State and explain whether solid A is an acidic or base compound. Solid A is basic. Okay, explanation. Group two, group two is alkaline earth metal. Okay, we can talk about this, but otherwise you can say is that hydroxide ion is formed. Hydroxide ion is formed. So this is MgOH2. Okay, this is this is tricky because metal oxide is also a base. Okay, and metal hydroxide is alkaline. And if it's not soluble, you call it base. I think Mg is soluble. Okay, let me ask. Mg plus steam. Sorry, my English is very broken because anyway, the AI you don't need to type too much. Okay, okay, I'm wrong. Okay, so MgO. Uh, okay, this is oxide. So I didn't remember the text good rightfully. Okay, so this is not. So it's Mg oxide. Okay, it become oxide. It's in the memory work for the metal with steam. This one, metal with water, metal with steam, and metal with acid. Okay, so MgO come out of metal oxide. Okay, so metal oxide is actually a base. Okay, metallic oxide is a base. So it form a base, right? Form a base means that it is basic. Okay, basic compound. Okay, acidic stuff like HCl you dissolve in water give you hydrochloric acid. Okay, so that's your basic compound you dissolve in water or vary with water will give you a base. Okay, so that's why you can call it alkaline compound. Magnesium react with gaseous iodine to form magnesium iodide. Write a balanced equation, chemical equation for it include state symbol. Okay, magnesium's Mg metal, right? Metal we don't add number, and then iodine is I2. Okay, chlorine, bromine, iodine, they're the same thing. Okay, so magnesium of iodide. Okay, magnesium is 2 plus, iodide is -1, so cross multiplied is 1, cross multiplied is 2, so MgI2. So formula is fixed. So 1 Mg1 I2, 1 Mgi2 is balanced. Okay, so no need anything. So this is solid. Iodine is solid in room temperature pressure. So solid come out. This is solid, I think. Yeah, it's crystal. No, it's a gaseous iodine. Okay, so gaseous iodine. G. Magnesium, they didn't say anything, so just put a solid. Okay. Iodine supposed in gas state, in room temperature and pressure is supposed to be solid, but they use gaseous iodine. It makes sense. Okay. So that's the idea. Magnesium iod. So anyway, this is balanced. Magnesium iodide dissolved in water to produce aqueous magnesium iodide. Magnesium iodide dissolved in water to produce aqueous magnesium iodide. That means just dissolve this guy become aqueous. Okay. Chlorine is bubbled through the aqueous magnesium iodide and replace displacement reactions of the wow. This is Then why? Okay, this is something that you might not bother, or you might not learn displacement reactions, and you don't need to care. It just follow what is they will guide you to along. Complete a word equation for these reactions: chlorine, magnesium iodide, and this. Okay, so two guys. Okay, so guess one guy first. Uh, uh, okay, chlorine. Chlorine is the guy for displacement. The displacement reaction is something we have. Uh, why is like displacement? It's just like just now substitutions. Okay? The guy that can go in actually can be rightfully replace the guy which have similar property. Okay, fluorine, chlorine, bromine, iodine, they are all group 7. So when the chlorine goes in to display the guy out, okay, that means this is the guy consider, and this guy within this two compound is being displaced by this guy. Okay, so chlorine is a gas go in, then the iodine got to come out. Okay, so it's the one of them got to be iodine. Up to you. You can write here iodine. Okay, so iodine go out, and then means the magnesium chloride will go in. Okay, so magnesium chloride IDE. Okay, this is a word equation, so you don't have balance. Describe what is observed during the reactions. Okay, what what you observe is gas, liquid, or solid kind of things happen. Do you see any spark, any color change? Okay, so chlorine is a gas, so a pale yellow gas, okay, is bubble through, right? Aqueous, right? Aqueous magnesium iodide. Okay, so iodide in aqueous form. Iodide in aqueous form. Iodine crystal is iodine crystal is purple. Okay, iodine or iodide in solution form is something that you might actually see every day. Like every day when you cut a wound, the time you apply iodine solutions, right? The color is from iodide solutions. Okay, so this is colorless. This is a brown solutions. Okay, your iodine solution normally you use in medical. Your wound is actually brown color. Okay, so we'll see pale yellow gas pass through the brown color solutions. Okay, then the solution turns iodine come out. That means our solution, so it might be crystal. Okay, so violet color crystal might form, and the solution will turn colorless. Okay, chloride is colorless. Okay, so you can see that the brown solution turn colorless, and then you can see violet crystal form. Okay, so that's what you see. Okay, violet crystal appear. Solution from turn from brown to colorless. Okay, aqueous bromine is used to identify unsaturated hydrocarbon. Name one unsaturated hydrocarbon can react with bromine. Okay, this is to test alkene. Alkene. Okay, alkene. Alkene. Okay, anyone will do. Okay, so just choose like ethene. Okay, ethene means two carbon, double bond chain. Draw a full short formula unsaturated alcohol identified this. Show all atoms and all bond. All atoms, all bond. Carbon. They didn't say use dot cross diagram. Okay, so all atom, all bond. Oh no, I'm wrong. Draw that. I will know I'm wrong. Okay, delete. Come on. Okay, okay, double bond. Okay, so I have two more. Okay, so done. Okay, so this is ethene. Okay. Sulfur dioxide SO2 is produced when the zinc is reacted with the one zinc blend with the ore. The ore zinc blend, don't know what's that, and solid sulfur is burned here. Describe the arrangement and movement of sulfur molecule in solid sulfur. Solid sulfur is burned in the air. I don't know what is this. Okay. Anyway, okay, I don't bother to check it. If we just talk about arrangement and movement of sulfur molecule in solid sulfur. Movement. Arrangement. Sulfur solid sulfur exists in the form of acid molecules. Okay. Okay. Within a molecule, eight sulfur atoms are bonded with covalent bond. Covalent bond. Okay. But and the weak force, right? That we call the Van der Waals force. Okay. When an intermolecular force holding the molecules together. Okay, and then that's the sulfur solid crystal. Okay, movement. Describe movement of solid molecule in solid sulfur. Movement. What is the movement? Movement of sulfur molecule in solid sulfur. Movement. It has vibration, rotation, and there's no translations. Okay, and rotation I think is hard also. So it have vibrations. Okay, molecular vibrations amongst molecule. Okay, atoms are bonded within the S8 lattice, so those are minor atomic vibration. I don't think we care about much. Okay, just vibrate among molecules. This is the movement it have. It cannot move, translate to any other places during your if you still remain as a solid sulfur. Okay. Sulfur dioxide is an atmospheric pollutant that is dangerous in building. Explain why sulfur dioxide is atmospheric dangerous in building. Is acidic gas. Okay. Uh, building. Okay, because building we can either corrode metal, acidic gas, so it can corrode metal, and it can also react with cement. Okay, cement is most carbonate compounds. Okay, cements of the building, you can corrode them. Okay, so corrosive for metal, then this is the building. Okay, those water pipe whatever are metal, right? Okay, so and those are cement of the building or limestone, all these things will get corroded also. Okay, so this acidic gas issue for them. For water and go to water, kill trees, kill fish. Okay, inhale in your lung, it will just irritate your lung and irritate your eyes also. So those are the six places, two for each way. Okay, zinc is used to make alloy brass. Say that what's mean by the term alloy. Alloy is means that uh, um, alloy is a mixture. Okay, first use the right word. It's a mixture with different metal, with more than one type of metal. Okay, one mark. Okay. Excessive zinc and excessive zinc oxide are created separately due to hydrochloric acid. Reaction produce the same soluble salt. Only one of the reactions will produce a gas, of course. Okay. State the name. The idea is this. Okay. These two guys are react with acids. Okay. Acid reactions in the acid chapter. We have acid and metal, and acid and base, right? Acid and base is neutralizations. Okay, neutralizations form salt and water. Acid and metal give you salt and hydrogen. Okay, that's that's the two reactions, and all metal all metallic metal oxides are base. Okay, so remember this is metal oxide, zinc oxide, so it's the base. So we form salt, and we form salt also, but zinc is a metal. So they're under two different category of reactions. So one will give you H2, one will give you water. Still the name of formula of the salt produced for each reaction, for both reactions. So the salt, okay, the acid, okay, is hydrochloric acid, so HCl, right? Okay, then this is zinc. The salt here got to be one positive ion, one negative ion. Positive ion is going to be zinc. Negative ion got to be from the acid. Okay, so it's chloride. Okay, so zinc chloride, chloride is minus, zinc is 2 plus. Okay, zinc is something that you got to remember because in transition elements, you got to remember zinc is actually 2 plus. Okay, so this is why I have a 2 here. So this is zinc chloride. Okay, formula ZnCl2. This one just check you whether you remember zinc is 2 plus. Describe a test for gas produced. The gas produced is hydrogen. Test for hydrogen is to have a burning splinter, right? Burning splinter, a pop sign. Pop sign appear, okay? A pop sign indicates the presence of H2. Describe how crystals of the salt are prepared from the mixture of aqueous salt. Crystal of the salt are prepared from the mixture of aqueous salt and unreacted zinc oxide. Okay, so zinc oxide mixture of the salt and unreacted zinc oxide. So that means I have zinc chloride and zinc oxide mixture. I got to prepare the salt. I only want zinc chloride. I don't want zinc oxide. Okay. So I will first I will first convert all zinc oxide to zinc chloride. Make sure the mixture of both is only even the zinc oxide also becomes zinc chloride. Okay. So we'll add hydrochloric acid in excess until no more gas. No more gas, right? No more gas means all my zinc no oxide got no gas. In excess until and until the solution turn acidic. Okay, I use the until pH lesser than 7. Is, it, is there any better way to do that? Okay, I just do a quick way. Okay, I got no time to think too much only. Okay, so I add excess HCl. Okay, excess HCl until the whole solution turns acidic, because if I still have zinc oxide, it will still keep neutralizing my HCl. Okay, the hydrochloric acid. So my hydrochloric acid is become make the whole solution acidic already. And that means no more zinc oxide can remove my acid. Okay, so that means I now have excess acids and salt. Okay, and then after I'm going to rinse it with ionized water. Rinse. Okay, rinse rinse them. It might actually dissolve to be a solution. This is this is this is very tricky. I got the zinc chloride. Zinc chloride. This paper is not simple. Okay, so let's do it again. Assuming if the mixture of this aqueous salt. Oh yeah, they give you this word. Okay, they give you this good word. Okay, evil there's kindness. Okay, actually it tells you this salt is soluble. Okay, a mixture of aqueous salt and unreacted zinc oxide. Zinc oxide is not soluble. Zinc oxide is oxidizing. Okay. Is zinc oxide soluble? I think it's not soluble. Insoluble in water. Okay, soluble acid alkali. Okay, so okay, so correct. Okay, so actually this is soluble and this is insoluble. So how to separate them? I don't even need to react them. So the point is that filter by paper, filtrations. Filtration will make the will make the salt in the solute there. Okay, sorry, will be in the solvent there. Oh, sorry. Yeah. Okay. So in the after filter the solutions. Okay, the solution we make. Okay, will be in the solutions, and then this zinc oxide will be in the residues. Okay, so get the solutions. Okay, I want to extract this salt, right? Get the solutions, and then evaporation to the point of crystallizations. Okay, evaporation to the point of crystallizations, and then you have the crystal. Okay, and then just dry them off among the filter paper. Dry. Then I will get the crystal. Okay, so don't think too much. Okay, it's just like that. 2 marks. Okay, done. Okay, good. Okay, so come to MCQ. Student experiment blah 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 produce soluble gas. Which apparatus allows them to measure the volume of gas most accurately? Gas syringe standard. Okay, syringe have all the marking. You know how many gas come in. You just go for the upward downward delivery. All these are roughly here and there. And this is for liquid. There's no way for solid using a burette. Okay, table shows the boiling point of the sum of element present is at okay. Which elements are liquid at 200 liquid means that at minus 200 time I'm below boiling point. Minus 1x6 200. I think this is liquid. This is not. This is not. Yeah, there's still gas at minus 200. Minus 200. Minus 200. Okay, so 1, 2, 3. Argon, ANO. ANO. ANO is B. Okay, which reactions which produce a gas that pops with a burning speed? Burning speed pop is hydrogen. Hydrogens. Hydrogen. Huh? Which reaction will produce a gas? Okay? Will produce a gas, produce hydrogen. So acid with metal with water also. Metal water. See, neutralization, no gas. Okay. Anyway, carbonate and will produce gas. Acid carbonate is in the chapter acid. Okay, carbonate will give you CO2. Okay, oxygen, methane combustions. Okay, CO2, H2. Acid alkaline neutralization, salt and water. Okay, so that's in the metal. Okay, metal with water, metal with steam, metal with acid. Remember? Diagram shows the arrangement, particle, blah, 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 three substance, blah, blah, blah. Which how describe XYZ? Now they are, this one seems to be like alloy possible, two mixture of noble gases also. Okay. This is like gas, okay, which is gas elements. Okay, so this is like small molecular compounds. Okay, so that they form molecules, something like HCl. Okay, so they are molecules also. So first one seems to be mixture. Second one seems to be elements. Okay, because the same kind, right? So the third one is a compound. So D. Which statement define the nucleon's mass number of elements, number of proton, neutron? Wow, this simple concept, I got two questions asked this. Okay, so this is very simple. Don't waste it. Electrons dot. Okay, so which describe happen when electron in the outer shells or type of the what atom or NH form a compound. Electrons are so when N and H together, okay, so N is in group 3, I'm sorry, group 5, so it's -3. H is in group 1, so 3, 1, so I have NH3. Okay, so it's ammonia. Okay, so they are covalent bond. Okay, so covalent compound. So like that, H, and H. Okay, each one contribute one share. Okay, so I have a lone pair here. Okay, so this is NH3. So this is the structure. So between them is the electron share, okay, and type of bond, okay, within this tree is our covalent. What are the chemical formula of the main compound in hematite and in limestone? I think. Okay, hematite we use lime to extract that. Okay, hematite is copper oxides. Okay, copper oxides. Okay, copper have copper 2 and copper 3. Okay, so the most oxidized one is copper 3. Okay, so you take out from the ground, it will be the most oxidized one. So it's copper 3 plus and oxygen 2 minus. So cross multiply Fe2O3. Fe2O3, Fe2O3, these two. Okay, limestone is calcium carbonate. Carbonate. Carbonate is 2 minus and calcium is 2 plus. Okay, group 2. So cross multiply, take a common factor, so CaCO3. What compound is used to treat acidity in soil? Okay, acidity in soil means that something can sort of neutralize acid, but then it can uh, slowly it's not like one pour everything we get reacted and become too alkaline for the soil. So that means it's only react with acid where needed. Okay, and so carbonate actually is the best choice, but we don't have it. So calcium hydroxide. Okay, is the standard things we pour to the ground to treat acidic soil. Why? Because it's the base. But calcium hydroxide, even though it's hydroxide, is not soluble. So that means, right, you put inside the soil, right, is a block of calcium hydroxide. But then my soil is acidic, so on the surface there, right, keep handling is dissolving the calcium hydroxide that will neutralize the acidic soil. Okay, and more acid will come over the react, so they will just react with those acid, and they become salt and all these things. And then when when the thing is that when neutralized already, right, then the rest is still remain as a solid block. It will not be diffused into the soil. Okay, so it can sustain for long. Okay, so this is the good things that having insoluble stuff put inside the soil, so that we don't just turn the whole soil from acidic to alkaline. Okay, we just try to neutralize those things is needed, because this is not soluble. Okay, so calcium hydroxide is not soluble. Answer is A. Sulfate can't really help. Okay, this is the neutral salt. Potassium chloride neutral salt, sodium nitrate neutral salt. All these are neutral salt. Only this is hydroxide, is actually a base. So you just use acid and base. You also tell you there's only one answer A. Good. pH value of the four aqueous solution is shown like that. Okay, if pairs of solutions are mixed, which pair must produce an acidic nature? Acidic mixture. mass. Okay, so solutions are mixed. Okay, so solutions, the pH cell, you mix them together, it's still acidic. So it's only acidic, add acidic, and guarantee it still remain acidic. Okay, right? So if it's alkaline acidic, you don't know the amount is how much, then you don't know which one will be more. Okay, so the whole thing might turn alkaline, might turn acidic, might be neutral, who knows? Okay, so mass produce. Okay, so that's why they highlight this for you. Acidic mixture. Okay, so P and Q. And atom mathematics blah 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 22 what is that? Hydrogen, helium, lithium, beryllium, Be. Okay, 22. Hydrogen, helium, lithium, beryllium. Yep, beryllium. Which element has chemical property most similar to X? So group 2. Okay, so this group 2. So every one here. So answer is B. Okay, this noble gas, this group 6, this group 4. Group 4. Okay, group 4, this guy is silicon. Okay, so B is answer. Cross that, make sure. Which row describes the trend in melting point and reactivity going down the group 1? Okay, group 1, right, is metal, so it's all metal structure. And metals, right, what holds the metal particle together, the atom hold them together, is the free electrons. Okay, is free electrons because they have the forces we call the metallic bond. The metallic bond present is all metal. This is one of the metals. So metallic bond is the electron C. Electron C that's actually holding the atom particle. So when the uh, electron, the free electron is the metallic bond should be stronger. Okay, I'll check about the metallic bond. Okay, but reactivity is for sure going down the group is increased. Okay, increase down the group because the electron is easier to be given away going down the group. The radius of the atom is greater and greater and greater. Okay, you got more number of electron cell, right? Okay, so this is why the last guy is easier to lose. Okay, so that's why going down the group is increased. Okay, so it's either this or this. Okay, so melting point, melting point, melting point, metallic bond. Yes and no. Yeah, I have more instances of electron disorderness, but my attraction between the electrons and particle will be weaker. And if that is the idea about, if holding the particle together is about the electrons C attracting the atoms together, then the force between the electron and the nucleus should be the dominant factor about whether how strong they can be held with each other. So I myself will bet first. I may be wrong. Okay? I may say that the melting point actually it should be easier to melt going down the group because it's getting weaker between the electron C and the atom. I will choose this, but I might be wrong. Okay, going down group 1. Okay, group 1 compound, group 1 and 1 metal going down the group, melting point. Melting point decreases as you move down the group, so I'm correct. Okay, so it's because the attraction between the electron C. Okay, it's actually the same thing. Okay, reactivity increase because these group 1 elements, right? They try to throw away the electrons in the last shell. Okay, so when going down the group, your radius between the last electron and your nucleus is further and further away. So electron is easier to go away. Easier go away is easier to donate away the electrons. So it's easier for reaction. So it's going down the group, it got to be more reactive. Okay, but then you talk about melting point, right? It's like melt. Once you melt, means the atoms are free to go with one another. They don't have to be bound together. So what is the initial things that hold them together? Is also the force between the free electron and the nucleus. That is what we call the magnetic bond. Okay, magnetic bond. Yeah. Okay. So if this is the force that holding the particle together, so weaker this force attraction it is, the melt is harder to hold the atoms in their respective positions. Okay, so therefore I say this is decreased down the group for melting point. Okay, but that's why I say I don't remember stuff if you understand it. Okay, so this is A is the answer. Okay, ChatGPT agree with me anyway. The reaction of four metal LMNO, okay, with water, steam, dilute hydrochloric acid are described. Okay, described. L, no reaction with cold water and steam. Now this is in the chapter on metal, water, steam, and acid, right? Cold water and steam is actually slow reactions with hydrochloric acid. Okay, so metal residues we learn is potassium, sodium, I need, okay, calcium, magnesium, aluminium. And then after that is the remember one zinc and tin. Okay, zinc, iron, tin, lead, then the hydrogen, then the spy come in. This is not metal. Okay, copper, mercury, silver, gold, platinum. Nobody care. Okay, so this is the list. Okay, so the idea of this trend right in the metal chapter actually you have this table. Okay, so to find out. Okay, and then you will have a group of guys that actually react with cold water. Cold water, I think it is something about from here to here. Actually, calcium don't quite react with cold water already. Okay, it's only group one. But I think there's some sizzling. Okay, so check it out. Okay, and then after that, this is warm water or steam. Okay, until aluminum is still react with steam. Okay, and then the third one is exit. Exit is until the hydrogen above. Okay, and also you have a reduction table, but don't care. Okay, this is the basic one. You got to care about it. Okay, so that's why I say, okay, if things like this, right, all will get reacted. L has no reaction cold water, so it's not in this range. Or steam also. Okay, so it's in Singan lag. Okay, it has no reaction with dihydroic acid. Okay, so it's Singan lag. Okay, so this is L. L is roughly here. N has N has no reaction with cold water. It has no reaction with steam and fast reaction with hydrochloric acid. Okay, so that means the N is roughly here. N. O has no slow reaction with cold water and the fast reaction with steam and vigorous. So O is roughly here. Okay. M is vigorously with cold water. So M is here. Okay, so MONL. So answer is D. Okay, so this one table you got to learn the whole chapter. Okay. Well, good questions. Okay, learn a lot. For iron nail, blah blah blah. Okay, some of the nails are coated. Coated with what? Coated. Which nail will rust first? Paint, grease, painted iron nail. And then rust first, right? What rust you need? You need oxygens, and you need water. Okay, actually, it will just form some alkaline kind of things. Okay. Okay, so the iron plastic coated, uncoated air and water. This answer is D. Coated with plastic, right? So the metal cannot touch the water. Painted with iron, so it's with paint, right? So you cannot touch the water and air. Grease, okay, you lay out oil, so it just repel the water and the air. Okay, so answer is D. Which statement about the recycling of metal is correct? Recycling. Metal ore are renewable resources, but it's all ore means you take from the ground, the kind of things, right? What's a renewable? You mean you smash to the ground, let it become ore again, and you go take it out? Is it? This is weird. Okay, so I don't choose when I don't have to. Recycling conserve the resources of metal ore. This weird. Okay lah, okay. Recycling the metal, because after you throw away the dustbin, you use the metal again. Actually, I can exploit lesser. Also, somehow it should be okay. Slightly better. Give a small tick for that. Recycling metal increase the amount of waste in the landfill site. Recycling metals increase the amount of waste in the landfill site. You're recycling them. Not really. Actually, it's supposed to decrease the metal appear in the landfill, right? Okay, so sort of things is okay, but this is politically correct. This is politically wrong, okay, because the recycle business is also create a lot of land waste. Okay, this is the reality. Okay, we live in reality, but we always believe in hypocrisy. Okay, so C is not answer supposedly. If you're good student, okay. Recycling metal always uses more energy than mining, extracting metal from. This is actually a big takes if you are politically not correct, okay? Because recycling does have a lot of other things, including manpower, trucks moving, all these things. Actually, use more energy, okay? Then you simply extract them from the furnace. To me, yes, okay, but politically correct, I gotta say this is no. Okay, so answer is B. Okay, remember, be a student, be a smart student. Okay, get your marks. Don't believe in these things. Don't go to open up the ugly mask of the government or some other people. Okay, so remember this. Okay, even those to me, D is a very very make sense stuff. Yes, doing extraction is expensive. Recycling seems to be conserving energy. You don't have to extract so much, but the whole recycling business is not just about the recycling part. Okay, a lot of people, a lot of fossil fuel, a lot of things, construction, all these things behind are all using energy that people do not calculate that in. Okay, they just calculate recycle one aluminum can, the kind of things, to go to compare with the extraction of the same piece of aluminum from ore. Okay, so actually it's not accurate stuff. Okay, so I always feel that recycling make our society worse. Okay, reduction of use is actually the correct way about saving the environment. Okay, but it's never recycling. Recycling is actually a business of hypocrisy. They make money, okay, by making some noise about it. Okay. Which statement about the reactivity of iron is correct? So answer is B. Remember B. Okay, it conserve. Okay, it save the environment. That's why we recycle. This is correct. Okay, so this is the way. Okay, recycle more. I don't have to mine so much. Okay, as if. Okay. Which statement about reactivity of iron is correct? Okay, so zinc iron like the iron is inside. Okay, iron is less reactive than magnesium. Yes. Okay, sodium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead. Okay, so magnesium is on somewhere on top. Okay, so iron is zinc, iron, tin, lead, the four of them. Okay, why I remember this piece? The first five it can be deduced from periodic table, and the first five is where you can react with steam until you react with steam. Okay, sodium, potassium, sodium, calcium, magnesium, aluminum. So after this, it can only react with acid. So that's why I start to remember about zinc antin lead. Because zinc antin lead will react with acid, and after hydrogen, no more dilute acids. Okay. Sometimes you say copper can react with concentrated sulfuric acid. This is not metal with acid. No, this is the oxidation power of concentrated sulfuric acid and turn the copper become copper oxide first, and then they walk a pathway of acid with base, because there's metal oxide. Acid base is actually neutralizations, so nothing to do with metal. It's about base. It's in the acid and base chapter. Okay, so don't be tricked. Okay, they always love to trick people. Okay, that's chemistry anyway. Okay. Iron is less reactive than copper. No, copper is below. Iron is more reactive than calcium. No, calcium on top. Okay. Iron is more reactive than sodium. Of course, sodium is the second guy. Come on. Okay, so all these are wrong. Okay, so the A is correct. A student makes three statements about oxides: aluminum oxides, and phosphoric. And phosphoric oxides only got three guys. Okay, so aluminum, zinc, and one more guy. I think it's tin. Yep. So in your syllabus, aluminum and zinc. I don't know even zinc is considered also. Okay, so if you didn't learn about zinc, so just think about aluminum oxides. Okay, so acidic oxide, okay, you dissolve water give you acid. Okay, basic oxide or metal oxide give you base. But there are exceptions like aluminum and zinc. These two guys, oxides you dissolve in water and can react with acid and can react with alkaline. Okay, they can neutralize both way. So they are both way reactive. We call it amphoteric. Okay, hydrogen oxide. Hydrogen oxide, come on. Hydrogen oxide is water. It's acidic, wrong. Okay. So remember, for metal oxide, it can either be basic or amphoteric. For non-metal oxide, it can either be acidic or neutral. Neutral means you dissolve in water, don't react with anything. Like hydrogen oxide is water, dissolve in water is just water. Don't react with acid nor alkaline. Okay, so it's not acidic nor alkaline, it's neutral. Iron-free oxide is metal oxide. It's either basic or amphoteric, and amphoteric only two guys, aluminum and zinc. It's not aluminum, not zinc, so it's basic. Okay, so 1 and 3 is correct. The equation for the complete combustion of propane, okay, all carbon becomes CO2, all hydrogen become H2O. That is all combustions. Okay, which value x, y, z balance equations? Okay, so let me zoom in a little bit and rub away the nonsense first. Okay, rub. Okay, sorry, Control Z, Control Z. Good. Okay, so carbon to carbon is 1 to 1, so this is 3 carbon here. Oh, this is back. 3 carbons here, so 3 carbon here. Because it's 1 carbon here, right? So Y is 3. Okay. So hydrogen, I got propane. Propane is C5H12. 1, 2, 3, 4, 5. So 3 of them here and 3 of them here and 2 here. So 2, 3. Okay, so it's 12. Yeah, they go to 12. Okay, so H12. Okay, CnH2n plus 2. Okay, so 2n plus 2 is 12. Okay, and 5 times 2 is 10. 10 plus 2 is 12. Okay, so that's why I get it. So this is supposed to be, oh, propane, not pentane. Right, right. One more again. C3H 3 times 2 is 6. 6 plus 2 is 8. So it's 8. So it's 8 here. So this is 8. So 8 here, 8 here, 8 here, 8 here, 8 here. Okay, so what is that? So there's 8 here, but there's 2 here, right? So therefore the Z is 4. This is 3. Okay? So 4 of oxygens, the 4O here, O, 4O here, and then I have 3 times 2 is 6 here. So I make it 10 oxygen atoms that I need. So this O2 here, so that's why you got to be 5. X is 5, Y is 3, Z is 4. Answer C. Structural formula of linoleic acid, or acids. Okay. Which term describes linoleic acid? Which term? They are polyunsaturated compound. Poly means polymerized, right? No, not polymerized. Poly means in organic chemistry means multi. Okay. polyunsaturated and saturated. Okay, it has double bond. Okay, it has double bond means that it can have addition. So if you can add if you can have additions, means you are unsaturated, then you can add additions. If you're saturated, then you cannot add anymore. The only thing you can do is to kick out a guy and chuck in a guy. So you normally go for substitutions. Okay. So since they have double bond, I can have additions. I have two sides. Okay. So you can have one after another additions. So I can have poly means multiple, unsaturated. Okay. Good. Are they hydrocarbon or are they just compound? Compound means anything else, okay? Hydrocarbon means only hydrogen and carbon. Okay, hydrogen and carbon. They are hydrocarbon, yes, of course. Okay, because you only see hydrogen and carbon, right? So they are polyunsaturated hydrogen carbons. Okay, you call it compound is also not wrong, but this is a better answer, better description, more sexy, more tailored to this scenario. Anyway. Propane react with bromine at the room temperature because this is the way we detect double bond. Okay, you pour bromine inside, the bromine color get decolorized because the BrBr got chucked into added additions added to the compound. So how does it added? Is there something with a double bond, and bromine BrBr open up, cleave here. Okay, so that this guy cleave here, and then one bond coming this way. So it become whatever it is, okay, the BR and the BR get added into it. From the BR itself, get added into it. Okay, so this guy add together become this. Once this like that, that means my bromine in the solutions, right, is disappeared. It's being used up to add it inside, okay? Then you can see the additions, okay? So that means it must add across a double bond, okay? So these two guys will be adjacent to each other. So only answer C is correct. Okay, adjacent to each other. That means double bonds supposedly to be here. Okay, before reactions. Okay, this guy is a substitutions. It's a free radical substitution. You need sunlight and do all this thing, and there's no additions into it. Okay, and then you have byproduct HBr come out if you have the kind of things. These two is don't know what kind of thing you have. Okay, so might be different substitutions. Then you have this product. Okay, so it must be C. Last question, okay? The oxide of element Z is produced by volcanoes. Oxides of element Z or volcanoes is cause the acidity in the acid ring. So it's most of the time is sulfur stuff. Sulfur stuff. Acid in acid ring. Nitrogen also can. But volcano, right? Lava, right? Then sulfur, you have sulfur smell, right? All these things, eh? Is this oxide. So SO2 or SO3 also, okay, part of the gas underground, the kind of things, or sulfur actually burn in the air, becomes sulfur oxide, or outside is the pollutants, okay, acid ring, right? Okay, so it can't be chlorine, it got to be sulfur. So this answer. What else? Oh, this 2022 already. Okay, so today that's all for the 2023 paper. Okay, hope you guys like it, and remember to click the like and subscribe. Okay, which really encourage me. Okay, thank you.